Moving on to the next question, which is asked from the subject transducer. So it is from the subject transducer. So second question in the series 5 for IN. IN is for 2 marks. So it is once again from the same topic, measurement of non-electrical quantities. So here a cantilever beam is there. So we'll go through the question. So a cantilever beam is there, which is tied at one end. You can see it here, fixed end. One is free to rotate. So a force is applied onto the cantilever beam, and now it has deflected to this position. So the displacement when measured from the rest position, which is when no force is applied, is found to be 1.34 mm. So the cantilever beam, when a force is applied, it has bent, or the displacement found is 1.4 mm. So here you can see that it has made with respect to the neutral point, or with respect to the origin, it has deflected by an angle of θ1. So now we are asked to find when it has been moved to θ2, which is given by the relation θ2 equal to θ1 plus 1 degrees. So when it has moved 1 degree more than θ1, what is the linear displacement x? So which is nothing but the quantity to be found out in mm. So that's what the question says. So now when the cantilever beam is moved to a new position, which is θ2, and θ2 and θ1 are related using this expression. So we are asked to find what is the linear displacement x. So we know that deflection is nothing but radius into 1 minus cos theta. So it is in terms of a circle. If you see, the derivation is, so if this is my center and this is my radius, so here this is also my radius. So this is the angle which is made. So using this is assumed to be a triangle. So if you can see, this area is assumed to be a triangle. So we get the deflection theta, which is nothing but r into 1 minus cos theta after simplification. So which is nothing but something like this. So here you have a triangle. This is of radius r. This is also r. So this is r cos theta. So on simplification, we get the deflection as r into 1 minus cos theta. Here in the first case, we are given the displacement as 1.34 mm. And the radius is given as 10 mm. You can see it here. R is equal to, so I just noted down here, R is equal to 10 mm. So I am substituting 10 mm here. So mm gets cancelled into 1 minus cos theta 1, which is nothing but the first displacement. So I get after simplification theta 1 as 30 degrees. So we can calculate theta 2 with the above relation. So theta 2 is equal to 30 plus 1, which is 31 degrees. So now I have the angle of deflection, radius. So I need to calculate the deflection in mm. So I can substitute all the quantities and I get the deflection as 1.428 mm. So here the answer is 1.428 mm.